There are weeks when the universe refuses to be background scenery, weeks when the night sky stops being a quiet dome of stars and starts behaving like a stage director with a flair for drama. The last week of September 2025 was one of those weeks. First came the novas. Two separate stars, hundreds of light-years apart, both reached critical mass in their slow, invisible deaths. In a single night, they flared into brilliance, each one detonating with the energy of 1 billion nuclear weapons per second. Their combined radiance traveled across the void, crossing centuries of darkness, only to arrive in our neighborhood of space within days of each other. Gamma rays and X-rays rained down on the inner solar system, invisible but merciless, a flood of high-energy radiation rewriting the normal background hum of cosmic static. Astronomers logged the coordinates and shook their heads at the timing. 2 novas in such close succession is rare, but not impossible. The textbooks had room for coincidence. Then SWAN woke up. Comet C, divided by 2025 R2, nicknamed SWAN, after the survey telescope that first caught it had been behaving itself, following the curve of brightness expected from a modest icy traveler 2 weeks past perihelion. But on the morning of September 26th, at 8:43 UTC, the coma brightened in a violent surge. The magnitude jumped from a quiet 6.5 to nearly 5.7 inches a matter of hours, a change so sharp you could measure it between sips of coffee. Its tail stretched outward like a sword slash across the constellations, growing to span 2.5 degrees of sky 5 full moons wide. Southern Hemisphere observers were the first to notice. In Chile, Argentina, South Africa, and Australia, amateur astronomers began flooding forums with images that looked almost too spectacular to be real. A shimmering plume of gas and dust, glowing faintly green, cutting across the sky like a river of phosphorescent smoke. Social media lit up with the news. A comet had decided to make itself visible to the naked eye in a matter of hours. SWAN had, in the language of comet observers, outburst. Coincidence, the skeptics said. Comets are volatile. They flare, they crack, they vent gas when sunlight penetrates deep into their crust. Outbursts are fireworks shows written into their DNA. But the timing was uncanny. 2 novas in the days prior, now a comet's sudden awakening. The pattern seekers raised an eyebrow. And then came the Sunday. On September 28th, precisely 48 hours and 43 minutes after SWAN's outburst began, active region 4232 on the Sun's surface erupted. The M6.4 solar flare unleashed more energy in 10 minutes than humanity has produced in its entire history. Satellites in geostationary orbit reported X-ray spikes, triggering radio blackouts across the sunlit half of Earth. Pilots in transatlantic airspace scrambled to adjust communications. HF bands collapsed. For a few tense hours, the solar system reminded our civilization how fragile its technological skin really is. But the flare was only the overture. Within hours, coronagraphs aboard the Solar and Heliospheric Observatory recorded the expanding bubble of a coronal mass ejection, CME, 1 billion tons of plasma hurled into space at nearly 2 million miles per hour. Its trajectory? Not toward Earth, mercifully, but not harmless either. The plasma cloud raced outward through the ecliptic plane, the very slice of cosmic geography where Comet SWAN was traveling. 3 events. A cosmic 1-2-3 punch delivered with theatrical precision. 2 novas, a comet's eruption, a solar flare, and a billion-ton CME. Within the space of a single week, 3 different corners of the universe seemed to conspire in rhythm. The scientists, of course, called it noise. Random events cluster all the time. Human brains are pattern-making machines. We find faces in clouds, conspiracies in coincidence, meaning in chaos. The sober line was clear. These were unrelated phenomena, stacked by chance. But even the skeptics hesitated, because when events happen with this kind of symmetry, with timing so razor-sharp it might as well have been scripted, you pause, you take a longer breath. You start to wonder, is this choreography or chaos? Let's line up the players. SWAN, a native comet, still carrying 4.6 billion-year-old ice in its heart, swinging past the Sun and heading toward its closest approach to Earth on October 20th, 10 million miles from our planet, close enough to dominate autumn skies. Atlas, the 3rd confirmed interstellar visitor ever discovered, lurking just behind the Sun's glare, nearly invisible from Earth. A cosmic wanderer on a hyperbolic trajectory, headed toward perihelion on October 30th, just inside Mars's orbit. The geometry is unnervingly neat. Two objects, one from our own backyard, one from beyond the stars, moving through the same turbulent sheets of solar plasma, both arriving at their moments of peak activity within days of each other. And then the Sun itself, restless in the opening act of solar cycle 25, flexing magnetic muscles it hadn't shown in years. If this were a novel, you'd accuse the author of heavy-handed foreshadowing. If it were a movie, you'd roll your eyes at the script's lack of subtlety. But this isn't fiction. It's orbital mechanics, stellar physics, and statistical improbability colliding in real time. September 2025 forced us to ask a forbidden question. What if coincidences sometimes aren't coincidences? Because here's the thing. Timing matters in physics as much as magnitude. A nudge at the right moment can topple an avalanche. A spark at the wrong instant can ignite a firestorm. And when cosmic events line up like this, you start to wonder if the universe is testing thresholds we don't yet understand. The official agencies, NASA, ESA, USGS, issued their disclaimers. No proven causal link exists between novas, comet outbursts, and solar activity. The Sun is too massive to care what a little comet does. Earthquakes on our planet remain immune to solar flares. The guardrails of science are clear. Stay in your lane, don't romanticize coincidence. But for every hardline skeptic, there were quiet voices saying, still. The novas delivered their flood of radiation days before SWAN's coma lit up. Still, SWAN's eruption preceded the Sun's flare by exactly 2 days. Still, Atlas, unseen behind the Sun, was racing toward its own encounter at precisely the same time. If this is choreography, the downbeat lands on October 21st. A new moon will darken the skies. SWAN will glide past Earth at its closest approach. Atlas will be closing in on perihelion, and the Sun, already restless, may have more to say. The stage is set, the curtain is rising, and somewhere in the mathematics of plasma physics and orbital mechanics, the answer waits. We don't know if we are about to witness the most elaborate coincidence in astronomical history, or the first clear sign that our solar system is more tightly wired, more electrically coupled, more alive with hidden connections than we ever dared imagine. Stay with me, because the sky has exploded 3 times already, and what happens next may change how we understand the very fabric of the cosmic neighborhood we call home. September 26, 2025 began like any other day for comet watchers. The rhythms were familiar. Observatories opening their domes before dawn, CCD cameras humming to life, amateurs checking star charts in the pre-dawn chill, the quiet satisfaction of logging faint smudges of light across the endless dark. Comet C, divided by 2025 R2, known simply as SWAN, had been an unremarkable presence, sliding along its orbit as predicted, its brightness curve obedient, its coma modest, its tail little more than a faint pencil mark on the sky. Then, in the space of a morning, everything changed. At 8 UTC, reports began trickling in from the southern hemisphere. SWAN had brightened, not by a little, but by a leap so startling, it forced observers to recheck their calibrations. Its apparent magnitude had jumped from 6.5 to 5.7 inches a matter of hours, a change so fast you could measure it between cups of coffee. By the time telescopes had adjusted their guiding software, the comet's character had transformed entirely. The coma glowed with a new intensity, and the tail, once a thin plume requiring careful imaging, now stretched extravagantly across the constellations. 2.5 degrees of sky were suddenly painted with a pale blue streamer, 5 times the apparent width of the full moon. The images flooded astronomy forums like a storm surge, grainy DSLR shots from backyards in Argentina, high-contrast CCD stacks from professional observatories in South Africa, wide-field exposures from Australia, where the tail sprawled like a banner in the sky. Social media caught fire, hashtags multiplying, number Comet SWAN, number green visitor, number sky explosion. To casual stargazers, it was a gift, a beautiful surprise, a reminder that the heavens still throw curveballs. To the professional community, it was something else, a puzzle and a problem. Comets flare, of course. They are messy time capsules, 4.6 billion-year-old leftovers of the early solar system, fragile bodies crusted with ice and dust. As they approach the sun, sunlight penetrates their surfaces, sublimating buried ices, venting jets of gas, and carrying dust into space. This process is predictable, producing the gentle arcs of light curves traced in textbooks. But sometimes, something more violent happens. Pockets of volatile gas suddenly vent, crust collapses, fissures open to reveal frozen reservoirs that erupt in geysers. The coma swells, the tail blooms, and a faint wanderer becomes a torch in the span of a few hours. That is what astronomers call an outburst. SWAN's September 26 outburst was textbook in form, but spectacular in scale. Its coma more than doubled in brightness. Its tail reshaped itself in real time, its ion filaments and dust lanes visible in backyard scopes. In a single night, it had gone from an astrophysical curiosity to a global headline. But brightness told only half the story. What SWAN truly became that morning was not merely brighter, but louder. It had turned into a plasma generator. When a comet vents, the gas streaming off its nucleus is not inert. Ultraviolet radiation from the sun ionizes the escaping molecules, turning them into charged particles. Those ions couple to the solar wind, attaching themselves to magnetic field lines that flow outward from the sun, like invisible rivers. The result is the comet's ion tail, a pale blue streamer stretching millions of miles into space. SWAN's outburst didn't just increase the brightness of its coma, it injected the solar wind with a flood of new ions and dust, a process plasma physicists call mass loading. The solar wind is ordinarily a steady gale of charged particles, but when a comet adds new material into that stream, local turbulence follows. Particle densities shift, shock fronts ripple both outward toward the planets and inward toward the sun itself. This mattered because of where SWAN was. The comet's orbit carried it close to the ecliptic plane, that thin slice of space where the planets travel and where the sun's magnetic influence is most complex. This region is home to the heliospheric current sheet, a vast, undulating boundary where the sun's magnetic field flips polarity. Imagine a ballerina's skirt, billions of miles wide, rippling outward through the solar system at nearly 2 million miles per hour. Objects crossing this skirt experience abrupt changes in polarity, density, and current flow. SWAN, newly active and venting clouds of charged gas, was now embedded in this electromagnetic battleground, pumping its plasma into the most turbulent highway in the solar system. And this wasn't ordinary plasma. Comets do not vent clean gases. They exhale clouds laced with dust, microscopic grains of rock and metal, each one capable of carrying electric charge. This creates what physicists call a dusty plasma, a bizarre fourth state of matter where charged grains rewrite the rules. In laboratory experiments, dusty plasmas self-organize into spirals, form lattice-like cells, even mimic neural networks. They defy the tidy equations of magnetohydrodynamics, producing non-linear effects, amplifying weak disturbances into sudden cascades. SWAN's outburst had created just such a dusty plasma cloud, a strange, unpredictable medium capable of shaping its environment in ways no textbook curve of brightness could predict. On Earth, the outburst was received with equal parts delight and alarm. Photographers rushed to capture the new tail, setting alarms for pre-dawn skies. Amateur astronomers in South America and Australia shared real-time updates, reveling in the beauty of a comet too bright to ignore. But professionals recognized the implications. Telescopes were re-aimed, schedules rewritten. SWAN was no longer a quiet background object. It was a frontline case study in solar system plasma dynamics. NASA's Parker Solar Probe was tasked with comparing its plasma readings against the timing of the outburst. ESA's solar orbiter was put on alert to watch for disturbances rippling outward from the comet's location. If SWAN's venting had injected enough material into the solar wind to alter its flow, these spacecraft would know. And still, the timing haunted the conversation. 2 novas detonating across the galaxy, then SWAN erupting, and then, precisely 48 hours later, the sun answering with its most powerful flare in months. Skeptics reminded everyone that random events cluster all the time. The cosmos is vast, coincidence is inevitable. But the unease was palpable, because science, too, is a human enterprise, and humans know the rhythm of patterns when they hear them. The real question wasn't whether SWAN had outburst. That much was obvious. The question was whether its outburst was part of something larger, a link in a chain that stretched from stellar explosions light years away to the trembling magnetic fields of our own Sunday. Could the novas have nudged volatile reservoirs inside SWAN, their flood of high-energy photons arriving just in time to trigger sublimation? Could SWAN's sudden plasma injection have seeded instabilities in the solar wind, a ripple that crept sunward until it pushed an already unstable active region over the edge? Could all three events, nova, comet, flare, be chords in a single cosmic progression? For now, the evidence was circumstantial, the kind of thing scientists dismiss as correlation without causation. But space does not care about human semantics. The sun was already restless, its magnetic fields twisting, preparing to release more eruptions. SWAN was still venting, its dusty plasma tail cutting through the heliospheric current sheet like a charged wire in a cosmic circuit. And beyond the glare of the sun, still hidden from human eyes, Atlas was racing toward its own confrontation with solar fire. If SWAN was the spark, Atlas might be the fuse, and the week that had already delivered novas, comets, and flares was not yet finished. The stage was still crowded, the lights still rising, and the play had only just begun. September 26, 2025 began like any other day for comet watchers. The rhythms were familiar. Observatories opening their domes before dawn, CCD cameras humming to life, amateurs checking star charts in the pre-dawn chill, the quiet satisfaction of logging faint smudges of light across the endless dark. Comet C, divided by 2025 R2, known simply as SWAN, had been an unremarkable presence, sliding along its orbit as predicted, its brightness curve obedient, its coma modest, its tail little more than a faint pencil mark on the sky. Then, in the space of a morning, everything changed. At 8 UTC, reports began trickling in from the southern hemisphere. SWAN had brightened, not by a little, but by a leap so startling it forced observers to recheck their calibrations. Its apparent magnitude had jumped from 6.5 to 5.7 inches a matter of hours, a change so fast you could measure it between cups of coffee. By the time telescopes had adjusted their guiding software, the comet's character had transformed entirely. The coma glowed with a new intensity, and the tail, once a thin plume requiring careful imaging, now stretched extravagantly across the constellations. 2.5 degrees of sky were suddenly painted with a pale blue streamer, 5 times the apparent width of the full moon. The images flooded astronomy forums like a storm surge. Grainy DSLR shots from backyards in Argentina, high-contrast CCD stacks from professional observatories in South Africa, wide-field exposures from Australia, where the tail sprawled like a banner in the sky. Social media caught fire, hashtags multiplying, number Comet SWAN, number green visitor, number sky explosion. To casual stargazers, it was a gift, a beautiful surprise, a reminder that the heavens still throw curveballs. To the professional community, it was something else, a puzzle and a problem. Comets flare, of course. They are messy time capsules, 4.6 billion-year-old leftovers of the early solar system, fragile bodies crusted with ice and dust. As they approach the sun, sunlight penetrates their surfaces, sublimating buried ices, venting jets of gas, and carrying dust into space. This process is predictable, producing the gentle arcs of light curves traced in textbooks. But sometimes, something more violent happens. Pockets of volatile gas suddenly vent, crust collapses, fissures open to reveal frozen reservoirs that erupt in geysers. The coma swells, the tail blooms, and a faint wanderer becomes a torch in the span of a few hours. That is what astronomers call an outburst. SWAN's September 26th outburst was textbook in form but spectacular in scale. Its coma more than doubled in brightness. Its tail reshaped itself in real time, its ion filaments and dust lanes visible in backyard scopes. In a single night, it had gone from an astrophysical curiosity to a global headline. But brightness told only half the story. What SWAN truly became that morning was not merely brighter, but louder. It had turned into a plasma generator. When a comet vents, the gas streaming off its nucleus is not inert. Ultraviolet radiation from the sun ionizes the escaping molecules, turning them into charged particles. Those ions couple to the solar wind, attaching themselves to magnetic field lines that flow outward from the sun like invisible rivers. The result is the comet's ion tail, a pale blue streamer stretching millions of miles into space. SWAN's outburst didn't just increase the brightness of its coma, it injected the solar wind with a flood of new ions and dust, a process plasma physicists call mass loading. The solar wind is ordinarily a steady gale of charged particles, but when a comet adds new material into that stream, local turbulence follows. Particle densities shift. Shock fronts ripple both outward toward the planets and inward toward the Sun itself. This mattered because of where SWAN was. The comet's orbit carried it close to the ecliptic plane, that thin slice of space where the planets travel and where the Sun's magnetic influence is most complex. This region is home to the heliospheric current sheet, a vast, undulating boundary where the Sun's magnetic field flips polarity. Imagine a ballerina's skirt, billions of miles wide, rippling outward through the solar system at nearly 2 million miles per hour. Objects crossing this skirt experience abrupt changes in polarity, density, and current flow. SWAN, newly active and venting clouds of charged gas, was now embedded in this electromagnetic battleground, pumping its plasma into the most turbulent highway in the solar system. And this wasn't ordinary plasma. Comets do not vent clean gases. They exhale clouds laced with dust, microscopic grains of rock and metal, each one capable of carrying electric charge. This creates what physicists call a dusty plasma, a bizarre fourth state of matter where charged grains rewrite the rules. In laboratory experiments, dusty plasmas self-organize into spirals, form lattice-like cells, even mimic neural networks. They defy the tidy equations of magnetohydrodynamics, producing nonlinear effects, amplifying weak disturbances into sudden cascades. SWAN's outburst had created just such a dusty plasma cloud, a strange, unpredictable medium capable of shaping its environment in ways no textbook curve of brightness could predict. On Earth, the outburst was received with equal parts delight and alarm. Photographers rushed to capture the new tail, setting alarms for pre-dawn skies. Amateur astronomers in South America and Australia shared real-time updates, reveling in the beauty of a comet too bright to ignore. But professionals recognized the implications. Telescopes were re-aimed, schedules rewritten. SWAN was no longer a quiet background object. It was a frontline case study in solar system plasma dynamics. NASA's Parker Solar Probe was tasked with comparing its plasma readings against the timing of the outburst. ESA's solar orbiter was put on alert to watch for disturbances rippling outward from the comet's location. If SWAN's venting had injected enough material into the solar wind to alter its flow, these spacecraft would know. And still, the timing haunted the conversation. 2 novas detonating across the galaxy, then SWAN erupting, and then, precisely 48 hours later, the Sun answering with its most powerful flare in months. Skeptics reminded everyone that random events cluster all the time. The cosmos is vast, coincidence is inevitable. But the unease was palpable, because science, too, is a human enterprise, and humans know the rhythm of patterns when they hear them. The real question wasn't whether SWAN had outburst. That much was obvious. The question was whether its outburst was part of something larger, a link in a chain that stretched from stellar explosions light-years away to the trembling magnetic fields of our own Sunday. Could the novas have nudged volatile reservoirs inside SWAN, their flood of high-energy photons arriving just in time to trigger sublimation? Could SWAN's sudden plasma injection have seeded instabilities in the solar wind, a ripple that crept sunward until it pushed an already unstable active region over the edge? Could all 3 events, nova, comet, flare, be chords in a single cosmic progression? For now, the evidence was circumstantial, the kind of thing scientists dismiss as correlation without causation. But space does not care about human semantics. The Sun was already restless, its magnetic fields twisting, preparing to release more eruptions. SWAN was still venting, its dusty plasma tail cutting through the heliospheric current sheet like a charged wire in a cosmic circuit. And beyond the glare of the Sun, still hidden from human eyes, Atlas was racing toward its own confrontation with solar fire. If SWAN was the spark, Atlas might be the fuse. And the week that had already delivered novas, comets, and flares was not yet finished. The stage was still crowded, the lights still rising, and the play had only just begun. October crept closer, and with it came the sense that something was aligning, not just in the sky but in the rhythm of the weeks themselves. Astronomers are used to geometry dictating destiny. Planets dance in ellipses, comets sweep along stretched ovals, gravity sets the steps. But what unfolded in the third week of October 2025 felt less like the clockwork of Newton and more like choreography, as though the universe itself had rehearsed the timing. On October 20th, Comet SWAN approached Earth at just over 10 million miles, a cosmic handshake by comet standards, close enough to dominate the pre-dawn skies of both hemispheres. Its outburst had settled into a steady roar, the coma still inflated, the tail still sprawling across constellations like a river of smoke caught in an invisible gale. Naked-eye observers could spot it without aid, a faint blur against the dark, but through binoculars and telescopes the sight was undeniable. SWAN had become the brightest comet in years. The next day, October 21st, the moon went dark. A new moon meant no lunar glare, no competing light. For the first time in decades, a bright comet passed near Earth, under the darkest possible skies. Amateur astronomers prepared for the show like a once-in-a-lifetime festival. Social media buzzed with viewing guides, sketches of star maps, reminders to look east just before dawn. The public marveled. But in professional circles, the tone was different. This wasn't just a viewing opportunity. It was geometry in its purest form, objects moving into alignments that begged questions. Because while SWAN swept near Earth, hidden just behind the sun's blinding glare, another traveler was approaching perihelion. The interstellar wanderer, Atlas, the third confirmed object from beyond our solar system, was reaching the point of closest approach to the Sunday. On October 30th, it would pass just inside the orbit of Mars, a hyperbolic curve that would never close, a brief interlude before it slipped back into the void. From Earth, Atlas was invisible, lost in daylight. But from the perspective of orbital mechanics, its path traced dangerously close to resonance with SWAN. Two objects, one local, one interstellar, both active, both streaming plasma into the heliospheric current sheet, both cresting toward maximum activity within the same 10-day window. The geometry deepened. SWAN's trajectory kept it embedded in the ecliptic plane, weaving through the same magnetic sheets that draped the sun's influence across billions of miles. Atlas, though tilted, traveled within just 5 degrees of that same plane. Their paths didn't intersect directly, but they rhymed parallel notes in the same cosmic score. And at the center of it all burned the sun, restless in the rise of solar cycle 25, flaring and twisting as though conducting the performance. For the pattern seekers, October 21st became a date circled in red. A new moon, SWAN at its closest, Atlas hidden but accelerating toward perihelion, the sun already primed for more activity. It was the kind of lineup that demanded interpretation. Coincidence again, said the cautious voices. The geometry is inevitable, they argued. With enough objects in motion, alignments will happen. But the skeptics couldn't erase the timing. The novas in late September, SWAN's outburst days later, the sun's flare 48 hours after that, and now this. A cosmic tableau where Earth, SWAN, the Sun, and Atlas all played their roles under the black curtain of a new moon. What made it stranger was the backdrop. The heliospheric current sheet was rippling, more turbulent than models had predicted, its magnetic folds exaggerated by the sun's activity. Parker Solar Probe sent back data of particle densities surging, electron flows surging and collapsing, like waves against invisible shores. ESA's solar orbiter recorded magnetic field reversals sharper than expected, jagged peaks on plots that should have been smooth. The sheet was alive, unpredictable, a ballerina's skirt tearing at the seams. And in that chaos, 2 comets and a star seemed to be weaving something larger. For the public, the spectacle was beautiful. Reports came in of SWAN's tail stretching across rural skies, photographs stacking exposures to reveal filaments like threads in a glowing tapestry. For scientists, the spectacle was unnerving. Geometry is supposed to reassure predicted positions, orbits plotted decades in advance, alignments that prove the universe is orderly. But here the geometry felt charged, less like mathematics and more like intent. 2 travelers arriving together, the moon obligingly absent, the sun already restless. It was as though the stage manager had dimmed the lights at the perfect moment. Behind the technical reports, the whispers grew. Could the novas have been the overture, SWAN the soloist, the sun the percussion, and Atlas the unseen crescendo waiting to arrive? Was this coincidence stacked upon coincidence, or were we glimpsing connections our models refuse to admit? Plasma physics tells us the solar system is a web, charged currents linking bodies across millions of miles. If that's true, then geometry isn't just coincidence, it's wiring. On October 21st, telescopes turned skyward in record numbers. Ground-based observatories charted SWAN's expanding coma. Spacecraft recorded the solar wind, watching for signatures of the CME that had already torn through SWAN's tail days earlier. Amateur astronomers logged images that captured the comet's faint green glow, the telltale signature of diatomic carbon fluorescing in sunlight. Data accumulated, but meaning lagged. For every measurement, another question. And still, Atlas remained invisible, its drama unfolding just out of sight. When it finally emerged from solar glare in November, its secrets would be laid bare. But by then, the geometry would have passed. The October convergence would be over. The opportunity for correlation, for coupling, for choreography would be gone. Observers knew this. That's why they leaned forward, staring not just at SWAN but at the entire sky, waiting for a signal that might tie the pattern together. If coincidences are the laziest explanation, October 21st was a temptation to be lazy. And yet, the geometry was undeniable. Earth in darkness, SWAN at closest approach, Atlas in hiding but burning toward perihelion, the sun unstable, the current sheet alive. Whether or not it meant anything, it looked like something. And sometimes, in science as in art, what looks like something is enough to open the door to wonder. The night passed, the comet glowed, the moon stayed dark, the sun crackled unseen behind the horizon. Nothing catastrophic happened. No auroras out of season, no global blackouts, no apocalyptic flare. But meaning doesn't always come wrapped in fire. Sometimes it arrives as a whisper, a geometry too precise to dismiss, a reminder that the sky is not empty but alive with relationships. As dawn broke on October 22nd, astronomers turned to their data. The world went back to work. But those who had stayed awake felt it, the sense that something had been staged, that the universe had leaned close and asked us to notice. Atlas was still waiting behind the Sunday. The story wasn't over. Geometry had set the stage. The next act would reveal whether choreography was real. Patterns haunt us. They tug at our minds, demanding attention, whispering meaning where perhaps none exists. Science trains us to resist that pull, to demand rigor, to insist that correlation is not causation. But in the autumn of 2025, as the data poured in, even seasoned astronomers found themselves glancing at the sequence of events with a trace of unease. The timeline was brutally clean. September 23rd, twin novas erupt across the galaxy, their light crossing centuries of darkness to reach our neighborhood within days of each other. September 26th, Comet SWAN outbursts violently, its coma swelling and tail exploding across the constellations. September 28th, the Sun fires an M6, 4-class flare, followed by a billion-ton CME slamming into the ecliptic plane. 3 notes in a chord, evenly spaced, building in intensity like a crescendo. Star, comet, star, coincidence, said the official line. Novas cannot influence comets across such distances, the energy flux is far too small. A comet's outburst is a local affair, driven by sunlight and buried ice, nothing more. And the sun? The sun erupts because its magnetic fields tangle and snap. That is what stars do. But the neatness of the cadence made coincidence sound less like a safe answer and more like a dismissal, an excuse to close the book too early. Consider the novas. V794 Sagittari and V935 Centauri, both faint stars invisible to the naked eye, both detonating in thermonuclear fury within days of each other. The gamma-ray flux at Earth's distance was indeed minuscule compared to the sun's constant brilliance. But comets are not planets. They are fragile, porous, riddled with volatile ices, poised on the edge of sublimation. It would not take much a fractional increase in energy, a trickle of high-energy photons to destabilize a buried pocket of gas. Could the novas have provided the final nudge? SWAN's outburst followed within days. It was not the first comet to erupt suddenly, nor the last. But the scale was dramatic, and the timing uncanny. And then, exactly 48 hours later to the second, the sun erupted. Here the skeptics grew most uneasy. SWAN had vented plasma into the heliospheric current sheet, dumping ions and dust into the solar wind. That material could not possibly travel back upstream toward the Sun in time to trigger anything, at least not according to conventional models. The solar wind flows outward, not inward. But plasma is nonlinear. Disturbances can propagate in unexpected ways. Small perturbations can amplify under the right conditions, and the Sun's active region had been restless, close to the edge. Could SWAN's sudden injection have tipped the balance? No one could prove it, but no one could entirely rule it out either. The comparison to dominoes became irresistible. A nova flares, photons race across the void, SWAN destabilizes and erupts, the solar wind shifts, the Sun lashes out. A chain reaction, improbable yet strangely elegant. The analogy echoed through conference calls and late-night email threads. Dominoes falling across scales so vast they mocked imagination. From stars hundreds of light-years away to a 10-mile wide ball of ice to a star at the center of our system, all within the span of a single week. Skeptics countered with statistics. Given the number of stars in the galaxy, novas happen frequently. Given the number of comets in the solar system, outbursts occur often. Given the restless nature of the Sun, flares are inevitable. Stack enough dice rolls and patterns will emerge. The universe does not conspire, it simply offers coincidences for our brains to embroider. And yet, the cadence lingered. The rhythm was too neat, too human. 3 events, evenly spaced, building in scale. It was as if the cosmos had struck a drum 3 times and dared us not to hear the beat. Behind the arguments lurked something deeper. The suspicion that we might not fully understand the way energy flows through the solar system. Plasma physics remains the least forgiving corner of astrophysics, the place where equations grow unstable, where small changes explode into chaos. The heliospheric current sheet is a river of magnetism more complex than any fluid on Earth. Comets inject dust and ions into that river like stones into a stream, sending ripples both downstream and, perhaps in ways we do not yet grasp, upstream. Energy does not always flow in the directions we expect. What unsettled the discussion most was the symmetry of the timing. Not just days apart, but 48 hours and 43 minutes between SWAN's outburst and the Sun's flare. To the second, the cadence matched. A skeptical voice could argue it was meaningless, that the precision was an illusion, the human mind snapping lines across dots that do not belong together. But the timing was undeniable, and in science, even coincidences demand explanation. The pattern seekers framed it differently. They spoke of coupling, of systems whispering to each other across voids of space, not causal in the simple sense, but resonant, like a string vibrating in sympathy with another across a room. The novas strummed the first chord. SWAN quivered in response, and the Sun, already taut with magnetic strain, snapped to the rhythm. Choreography, not chaos. By the second week of October, the debate had hardened into 2 camps. One insisted on randomness, warning that to indulge speculation was to wander into pseudoscience. The other admitted coincidence, but argued that coincidence itself might be the clue that perhaps our models of energy flow are too narrow, too local. Perhaps the solar system is more tightly wired than we think, a network where distant sparks can set local fires. Meanwhile, SWAN continued to vent, its coma steady, its tail stretching, battered by the CME that had slammed into it days earlier. The Sun continued to twist and flare, active regions crawling across its face, and Atlas, hidden behind the solar glare, inched closer to perihelion, carrying its own anomalies, its own mysteries. The chain might have ended with the Sun's eruption. It might already have been coincidence stacked 3 high, never to repeat. But the cadence left watchers restless. Once you hear a rhythm, you wait for the next beat. And October promised more alignments, more opportunities for the pattern to prove itself or collapse into noise. The safe answer remained the same: coincidence. But the safer answer had begun to sound less convincing, like a note held too long in a song that demands resolution. And so the world watched, waiting to see if the drumbeat would strike again. By mid-October 2025, the data streams from space probes painted a picture that was anything but ordinary. Parker Solar Probe reported subtle density shifts in the solar wind, tiny yet persistent anomalies in particle counts that didn't match model predictions. Solar Orbiter recorded magnetic field reversals that looked jagged and sharp, as though the current sheet itself had been disturbed. Ground-based radio observatories noted whispers of ionized turbulence, faint distortions, hinting at unseen waves rippling through the heliosphere. It was as if the solar system's great invisible rivers of plasma were suddenly restless, stirred by something more than chance. Into this confusion slipped a hypothesis, whispered first in technical side sessions at conferences, then leaking into research papers and late-night conversations between scientists who wanted to wonder without risking their reputations. The idea was simple, almost too simple. What if comets act like electrodes in a cosmic circuit? The theory came with a name that sounded more like science fiction than science: the plasma bridge hypothesis. It suggested that comets, especially during outbursts, do more than vent gas and glow with sublimated ice. They inject charged dust and ions into the solar wind in such quantities that they can create localized bridges of conductivity, temporary circuits that allow currents to flow differently, more directly, across vast distances. In this framing, SWAN's outburst wasn't just a flare of beauty. It was the equivalent of plugging a live wire into an already overloaded circuit. The novas had strummed a chord across space. SWAN had amplified it, building a conductive bridge in the current sheet. And the sun, restless and primed for instability, had felt the resonance and fired back. Mainstream solar physicists scoffed. The sun is too massive, its plasma dynamics too overwhelming, to be influenced by a speck of ice and dust a few kilometers across. To them, the plasma bridge hypothesis was a distraction, a poetic metaphor without grounding. Yet the data refused to stay quiet. The symmetry of timing between SWAN's outburst and the sun's flare was too sharp, the anomalies in the solar wind too coincidental. The hypothesis offered a narrative, a way to connect the dots, however tenuous. Those willing to consider it pointed to laboratory experiments in plasma physics. In dusty plasmas created on Earth, researchers had observed phenomena that bordered on eerie, self-organizing filaments, spiral structures forming spontaneously, complex waves propagating in ways no linear equation predicted. Dust particles, once charged, did not simply behave like ions. They introduced chaos, non-linearity, feedback loops. Entire patterns emerged, behaving like systems far larger and more organized than the parts suggested. Why should the solar system's dusty plasmas behave differently? If SWAN had created such a dusty plasma cloud and injected it into the heliospheric current sheet, perhaps it had carved a temporary bridge, a filament of altered conductivity stretching across millions of miles. In such a medium, the sun's already stressed magnetic fields might have felt the disturbance, not as a direct push, but as a sympathetic resonance. In this analogy, the sun was not knocked into eruption by a comet's whisper, but coaxed into release by a tuning fork vibrating at just the wrong frequency. The hypothesis was seductive because it carried a certain narrative elegance. It explained the chain of events as something more than coincidence: novas as distant strums, SWAN as amplifier, the sun as resonant drum. It gave geometry meaning, linked plasma physics with cosmic timing, and offered a mechanism, however speculative, for how such disparate events could align. Yet the plasma bridge hypothesis was also dangerous. It invited comparisons to fringe theories long dismissed by mainstream science, echoes of ideas about electric universes and cosmic circuits often used to explain away real physics with mystical overtones. Serious scientists tread carefully, unwilling to be seen entertaining such notions. But quietly, in private, the conversations grew bolder, because the data kept taunting them. Parker Solar Probe's instruments recorded unusual wave structures in the solar wind in the days after SWAN's eruption, fluctuations that resembled Alfvén waves, oscillations in plasma that carry energy across vast distances. These waves seemed sharper, more coherent, as though something had focused them. At the same time, Solar Orbiter tracked particle distributions that shifted abruptly, not gradually, as though a switch had been flipped somewhere in the system. None of it was conclusive. All of it was intriguing. If comets really could create plasma bridges, then the solar system was less a collection of isolated orbits and more a web of conductive filaments, a living circuit where events could ripple in ways we barely understand. The sun, comets, even planets could interact through this web, not just through gravity but through magnetism and plasma. The implications stretch from astrophysics into philosophy. The solar system not as clockwork but as symphony, its instruments wired together in ways we are only beginning to hear. Of course, skeptics were quick to point out the flaws. The distances involved are staggering. The densities of cometary plasma are minuscule compared to the solar wind's ocean of particles. To imagine such faint whispers influencing the roaring storm of the sun seemed absurd. And yet, plasma physics is not intuitive. Nonlinear systems magnify the small into the large. Chaos theory whispers that tiny disturbances can cascade into storms. Who is to say the sun is immune to butterfly effects written in plasma? By the time October's third week arrived, the plasma bridge hypothesis had become a ghost in the conversation, unacknowledged in official reports, but lurking in the background of every late-night analysis. It was the theory no one wanted to claim, yet no one could entirely dismiss. SWAN glowed on in the sky, its tail shimmering like a neon wire stretched across the heavens. The sun bristled with activity, magnetic fields twisting, promising more eruptions. And Atlas, the interstellar visitor, closed in on perihelion, its own chemistry and behavior still hidden behind solar glare. If SWAN had built one bridge, could Atlas build another? That was the question that haunted October. Because if SWAN had been a spark, perhaps Atlas would be a torch. And if the solar system really was wired together in ways we do not yet understand, then the stage was far from quiet. The next beat of the rhythm could shake more than tales of comets. It could shake the sun itself. Patterns do not begin with SWAN, nor with Atlas. If you trace the thread back far enough, you find echoes moments when the universe seemed to play with rhythm before. The autumn of 2017 was one of those moments, remembered first for the shock of an interstellar visitor, but later for a chain of events that, in hindsight, reads like a rehearsal for 2025. October 2017, the Pan-STARRS survey in Hawaii spotted a strange, elongated object tumbling through the solar system. It was dubbed 1I Oumuamua, the first confirmed interstellar object ever detected. At first it was assumed to be a comet, but as observations accumulated, it betrayed no coma, no tail, no obvious outgassing. Yet it moved as though pushed by something other than gravity, accelerating ever so slightly on a trajectory no asteroid should follow. The debate erupted: icy shard or alien artifact, natural or technological? The questions remain open even now, but the timing of its arrival carried its own resonance. Because just as Oumuamua swung past the sun itself erupted in one of the most intense flaring episodes of that decade. Solar cycle 24 was near its waning years, activity declining overall, but October 2017 produced a cluster of X-class flares, powerful bursts that slammed into Earth's magnetosphere. Auroras rippled far south. Power grids braced. Satellites felt the storm. At nearly the same time, Mexico was struck by a devastating earthquake, an event that some recklessly, perhaps connected to solar activity. The official line was clear: no causal link. Earthquakes are born of tectonics, not plasma. Interstellar visitors follow gravity, not destiny. Solar flares erupt from magnetic reconnection, not cometary whispers. Yet even then, whispers of suspicion spread. The coincidence was too sharp, the timing too clean. An interstellar object passes. The sun lashes out. The Earth trembles. 3 beats, a rhythm, almost identical to the sequence we are witnessing now. To most scientists, the memory of 2017 is framed by frustration. Oumuamua was observed too late, too briefly, to resolve its mysteries. By the time telescopes truly focused, it was already retreating into the dark, leaving only questions and a bitter taste of missed opportunity. But for those inclined toward pattern, the lesson was different. The first interstellar object came with a rhythm of solar violence, a choreography no one could explain. And now, in 2025, we are watching a sequel unfold. Oumuamua was first, Borisov second, Atlas third. One an enigma, one a comet, one something stranger still. Atlas is approaching perihelion just as SWAN flares, and the sun grows restless, just as novas detonate across distant constellations. The parallels to 2017 gnaw at the imagination. There is even the matter of geography. In both years, Earth was a spectator placed almost too perfectly. In 2017, Oumuamua's path aligned neatly with Earth's observational window. allowing discovery at precisely the moment it mattered. In 2025, SWAN's closest approach coincided with a new moon, the darkest skies possible, granting humanity a front-row seat. Coincidence again, or choreography? Scientists who lived through 2017 are more cautious now. They remember the frenzy, the headlines about alien probes, the crash of disappointment when data proved inconclusive. They caution against repeating the same mistakes, against rushing to declare meaning and rhythm. But younger astronomers, raised in the age of fast surveys and real-time data streams, push back. They argue that perhaps meaning was missed in 2017 not because it wasn't there, but because the framework for seeing it did not exist. Plasma bridges, non-linear, coupling, dusty plasma resonance ideas once whispered now feel less heretical. The memory of Mexico lingers too. September 2017 brought an 8.2 magnitude earthquake, followed days later by another deadly tremor in Mexico City. The tragedies were tectonic, not celestial, but their timing relative to solar activity inspired speculation. Were they connected? Geologists dismiss the idea. Earthquakes follow the movement of plates, not the rhythm of flares. But pattern seekers point to resonance again, to the possibility that the Earth, too, is part of the system, its ionosphere, its magnetic field, its crust, sensitive in ways not fully understood. Oumuamua's passage remains the unsolved mystery at the heart of it all. Was it a shard of ice ejected from another system, shaped by collisions we'll never witness? Or was it something else entirely, an object built, not born? The alien hypothesis remains the most controversial idea in modern astronomy, defended by a few, ridiculed by many, but never entirely erased. And woven into that debate is the question of timing. If Oumuamua was natural, its arrival during a period of solar unrest is coincidence. If Oumuamua was engineered, then perhaps the timing was intentional, a probe slipping past just as our star raged. Now Atlas takes the stage, and the timing is once again uncanny. The parallels to 2017 echo like a refrain. Interstellar object, solar unrest, geophysical unease. Coincidence or choreography? History does not repeat, but it rhymes. The rhyme of 2017 hums beneath the rhythm of 2025, daring us to listen, daring us to notice. Skeptics caution against memory bias. We remember the alignments, forget the misses. We highlight the coincidences that fit, discard the ones that don't. It is true. But science also demands we recognize anomalies, not sweep them aside. And the anomalies are stacking. First Oumuamua, now Atlas. First a sequence in 2017, now again in 2025. Once is chance, twice is pattern. And so the plasma bridge hypothesis gains historical teeth. Perhaps Oumuamua was not silent after all. Perhaps its passage through the solar system, even without obvious outgassing, disturbed the solar wind in subtle ways, building its own bridge, coaxing the sun to flare. Perhaps Earth, caught in the same geometry, felt the resonance in tectonic echoes. No proof, only whispers. But the whispers are louder now. Atlas is approaching perihelion. SWAN is still venting. The sun is restless. And those who remember 2017 are holding their breath, listening for the rhyme to become a chorus, because if history truly rhymes, then the next beat is already on its way. And this time, with better instruments and sharper eyes, we might not miss it. If 2017 was a warning, and 2025 is a crescendo, then the truth is that the solar system has been whispering hints all along. They are hidden in the archives, in events that seemed curious at the time but were quickly filed away as novelties. The sun has a memory though, and the comets that wander too close often carry the scars. One of the most dramatic lessons came in April 2007, when Comet Encke crossed the path of a coronal mass ejection. Encke is a familiar visitor, a short-period comet circling the Sun every 3 years. It was not new to astronomers, not special in composition, not mysterious in behavior. But when the CME struck, instruments on the stereo spacecraft captured the event in real time. The comet's ion tail, a glowing streamer of plasma millions of miles long, was simply cut off, severed. Within hours, it detached entirely, the luminous thread vanishing into the solar wind, while the nucleus, small and stubborn, continued venting gas. Like a lizard shedding its tail, Encke grew a new streamer within days. But the message was clear. The sun could slice comets apart with a single gesture, its plasma storms rewriting their structures in an instant. For most, it was a fascinating piece of space weather. For a few, it was a revelation. If the sun could sever a tail so cleanly, then the interaction between comet plasma and solar storms was more intimate than textbooks admitted. The geometry of that encounter, a comet crossing the sheet, just as a CME swept past, felt less like coincidence and more like choreography. But with no follow-up, the lesson faded. Enki returned on schedule, its scar forgotten. 7 years later, in October 2014, another whisper surfaced. Comet Siding Spring, a fresh arrival from the Oort cloud, swept within 87,000 miles of Mars, a hair's breadth in cosmic terms. Space agencies scrambled to protect their orbiters, fearing the dense coma might damage delicate instruments. But what unfolded was stranger. Mars, with its thin atmosphere and vulnerable magnetosphere, found itself bathed in the comet's plasma. Instruments recorded an induced magnetic storm, auroras flaring across the red planet's skies, its ionosphere temporarily rewritten. For hours, Mars wore a borrowed costume of plasma, as though the comet had painted the planet with its own signature. Again, the event was logged, analyzed, and shelved. Fascinating, yes, but an anomaly, a curiosity. The lesson was never connected to a larger pattern. The sun, the comets, the planets, each treated as isolated players, their interactions dismissed as rare accidents. And yet, looking back from the vantage of 2025, the pattern glows brighter. Enkei's tail severed, Siding Spring electrifying Mars, Oumuamua coinciding with solar storms, Swan exploding into brilliance just before the sun answered. The chorus of examples grows. Each one, alone, can be explained. Together, they begin to hum a tune. This is the tune that the plasma bridge hypothesis tries to formalize. The idea that comets and solar storms are not separate phenomena, but interacting components of a larger system. That the sun's eruptions and cometary outbursts sometimes dance to the same rhythm, exchanging energy, resonating across magnetic fields that span billions of miles. Critics point out that the evidence is anecdotal, the mechanism vague. Plasma is complex, but complexity is not licensed to invent causation. A severed tail proves only that the sun is violent. An aurora on Mars proves only that comets vent plasma. Coincidence explains the timing. But the skeptics forget that science itself is built from anomalies, from patterns noticed, from whispers that refuse to stay quiet. Forgotten solar mysteries are not truly forgotten. They wait, like buried seeds, until a new season of data makes them sprout. The archives of Enki and Siding Spring now look prophetic. They remind us that comets are not silent travelers but active participants, their plasma tails woven into the fabric of the heliosphere, vulnerable to its storms, capable of shaping its currents. The public, of course, remembers none of this. To most, comets are pretty lights, with no consequence. The sun is a background glow, taken for granted. But for those watching closely, the forgotten events are warnings. They tell us that when comets wander near, the solar system grows unstable, and that instability sometimes manifests in ways we cannot ignore. Which brings us back to 2025. Swan has already played its role, erupting just before the sun fired back. Atlas, larger and stranger, is approaching perihelion, hidden now but soon to reveal itself. If Enki's tail could be cut clean, what might happen to Atlas if a CME crosses its path? If Siding Spring could electrify Mars, what might Atlas do as it sweeps close to the same planet in March 2026? The possibilities tremble at the edges of imagination. The geometry is lining up again. The forgotten mysteries are no longer just curiosities. They are precedents. They suggest that what looks like choreography might actually be choreography. The sun and the comets may be partners in a dance we have only begun to hear. And so October's skies grow heavier with expectation. Astronomers pore over old data, reanalyzing Enki, Siding Spring, even the faint traces of comets long since gone. They find hints, echoes, small signs that perhaps the solar system has always been wired more tightly than we knew. They publish cautiously, hedging their language, fearful of ridicule. But the whispers spread anyway, because Swan glows, because Atlas waits, because the sun is restless, and because forgotten mysteries, once remembered, refuse to fade again. The chorus is building. The next note is Atlas. By the last week of October 2025, Atlas had vanished behind the sun's glare. To ground-based telescopes on Earth, it was invisible, swallowed by daylight. The irony was sharp. The most important interstellar visitor of our lifetime was performing its closest approach to the sun at the exact moment when our planet was blind. For weeks, the only eyes available belonged to robots circling another world. Mars became the front-row seat. Orbiters like ESA's Mars Express and NASA's MAVEN, along with the Trace Gas Orbiter from the ExoMars mission, were uniquely placed to watch the drama unfold. From their vantage point, Mars trailed the sun at just the right angle. Instruments calibrated to study thin atmospheres and tenuous auroras suddenly had a new assignment: point outward, track Atlas. The geometry was uncanny. On October 30th, Atlas reached perihelion, passing just inside the orbit of Mars, at about 1.4 astronomical units from the Sunday for Earth. It was a hidden event. For Mars, it was spectacle. Cameras captured the faint smudge of its coma, glowing with a strange forward-facing plume. Spectrographs read a chemistry that confounded expectations. Carbon dioxide dominating, water surprisingly scarce, nickel lines blazing without the iron that normally accompanies them. Atlas looked less like a comet and more like a laboratory experiment gone wrong, a recipe that broke the rules. But the strangest observations came not from the images, but from the numbers. MAVEN's instruments, designed to sniff the Martian ionosphere, registered fluctuations when Atlas crossed the sky. Tiny oscillations in plasma density, cycling in patterns that looked less like noise and more like rhythm. Every few hours, the readings ticked upward, then dropped, then ticked upward again. The oscillations did not match the rotation period predicted for Atlas's nucleus. They were faster, tighter, pulsing like a heartbeat. For scientists, the anomaly was a provocation. Was Atlas rotating irregularly, tumbling in a way models had missed? Was its nucleus fractured, releasing gas from multiple vents at staggered intervals? Or was something else shaping its emissions? Something more like regulation than randomness. The safe explanations lined up first. The wild ones hovered in the background, unspoken but insistent. Meanwhile, cameras recorded something even harder to ignore. On October 31st, less than 24 hours after perihelion, Atlas flickered. For a brief moment, just seconds, the brightness of its coma dropped sharply, then recovered. It was not a gradual dimming but a blink, as though a shutter had closed across its light. The orbiters logged it independently. The data was clean. Something had caused Atlas to vanish, however briefly, from sight. Theories raced ahead of the facts. Perhaps a jet of dust had briefly thickened the coma, blocking the nucleus. Perhaps a fragment had broken free, altering the reflective geometry. Perhaps, in the glare of the sun, instruments had been confused by a solar spike. Each explanation was possible, none entirely convincing. The blink refused to settle into a box. For those inclined toward speculation, the blink carried other meanings: a controlled modulation, a signal masked in cometary glow, an interstellar visitor that not only defied physics but announced itself. The idea was dismissed immediately in official channels. Anthropocentric fantasy, a desperate search for intelligence in noise. And, yet, late at night, in conversations off the record, the possibility hung there like a dare. Mars, for its part, became a witness to something stranger than anticipated. Just as SWAN had electrified the heliospheric current sheet weeks earlier, Atlas seemed to be stirring the plasma environment near Mars. Auroral activity spiked in the planet's thin atmosphere, glowing arcs visible in ultraviolet imaging. The coincidence was obvious. Atlas vented, Mars responded. The sun was the source of the plasma, but Atlas had disturbed the flow. The planet glowed as though acknowledging the interstellar guest. For the public, none of this was visible. Earth still sat blind behind the sun, its telescopes waiting for November to bring Atlas back into the night sky. News reports carried little more than speculation. Scientists confirm perihelion, instruments recording data, stay tuned. But for those watching the live telemetry from Mars, the sense of stagecraft deepened. SWAN had erupted and been cut by a CME. The sun had fired back. Now Atlas, hidden from Earth, blinked and pulsed, as though rehearsing for something larger. The geometry made the story heavier still. On October 21st, SWAN had brushed past Earth during new moon darkness, granting us perfect viewing. On October 30th, Atlas had brushed near Mars, granting our orbiters perfect vantage. 2 worlds, 2 comets, 2 alignments. Coincidence again, or choreography written across the orbits of planets themselves? As October closed, scientists prepared for November, when Atlas would re-emerge from solar glare. Ground-based telescopes would have their chance, spectrographs would slice its light, observers would log its position to absurd precision, but everyone knew the critical moments had already passed. Unseen from Earth but witnessed from Mars, a comet that pulsed out of rhythm, a blink that defied easy explanation, a planet's ionosphere responding like a drumhead struck. The data would take months to analyze, years to understand. Yet the whispers had already begun. Perhaps Atlas was not just another interstellar visitor, but the clearest sign yet that comets and stars and planets are wired together, their plasma fields overlapping, their rhythms entangled. Perhaps the solar system was showing us not random noise but system-level behavior, a choreography hidden in plain sight. And if that was true, then the blink of Atlas near Mars was not just a curiosity. It was a signal, not necessarily from intelligence, but from the system itself. A reminder that we are not watching isolated players, but a network, alive, humming, pulsing with energy. A reminder that the geometry of power extends beyond gravity into magnetism and resonance. Atlas was fading again, slipping deeper into its outbound leg, but the sense lingered. The universe had blinked, and we had noticed. November arrived, and with it came clarity, though not resolution. Atlas emerged from behind the sun's glare, faint but observable again in the night sky. Telescopes across Earth pivoted eagerly, capturing its glow, parsing its spectrum, timing its position to absurd precision. The raw data rolled in, more nickel than iron, more carbon dioxide than water, more mass than expected. Outgassing jets vented like silent flares, yet its orbit remained steady, unshaken by the forces that should have nudged it. A paradox written in green light, a visitor that breathed like a comet but moved like a mountain. The chain of events was undeniable. Novas flashed across the galaxy, SWAN erupted, the sun fired back, Atlas reached perihelion with a blink. Mars flared in auroras. Coincidence, said the official reports, repeated like a mantra. The timing meant nothing, but the cadence was carved into memory. Star, comet, planet, beats in a rhythm too precise to dismiss. The plasma bridge hypothesis lingered in the background, neither accepted nor rejected. Too speculative for peer-reviewed journals, too elegant to abandon. Scientists spoke of it in cautious tones, reminding each other not to fall prey to anthropocentric bias, not to impose meaning on randomness. And yet, late at night, the conversations turned poetic. If comets can bridge plasma currents, then perhaps the solar system is not a collection of isolated gears but a living network. If comets can stir auroras on Mars, perhaps the planets too are connected, vibrating in sympathy across magnetic fields that span billions of miles. For the public, Atlas remained little more than a headline. The third interstellar visitor, larger than expected, stranger than expected, soon fading into the dark. For those watching closely, it was something more. A mirror, a reminder that our models of the solar system are incomplete, that our explanations may be tidy but not true. By December, the excitement faded. SWAN dimmed, its outburst a memory. Atlas slipped further outward, its hyperbolic path ensuring it would never return. The sun quieted, its flares less dramatic, its storms less violent. Life on Earth carried on, oblivious to the cosmic rhythm that had pulsed across the sky. The headlines turned back to politics, economics, sports. The sky returned to its role as backdrop, but among astronomers, plasma physicists, and dreamers, the whispers did not fade. Instead, they deepened into something harder to shake, the sense that we had been shown a pattern, and that the pattern meant something. The pattern was not proof of aliens, not a smoking gun of design. It was subtler, more unsettling. It suggested that the solar system is not passive, not random, but interconnected in ways we do not yet understand, that novas can ripple through comets, that comets can ripple through the solar wind, that the sun can ripple through planets, that resonance matters as much as mass, that timing matters as much as scale. It suggested that coincidence is not always chaos but sometimes choreography. What do we call such a system? Some spoke of symphony, others of circuitry. Some reached for metaphors of weather, storms moving across the heliosphere. Some whispered of consciousness, though that was too much for most. The safest word was pattern. The most honest word was mystery. The final data packets from Mars told their own story. MAVEN recorded fluctuations in plasma density long after Atlas had passed, echoes of the blink, like ripples in a pond. The auroras faded but left signatures in the ionosphere that persisted for days, as though Mars itself had remembered. The pattern did not vanish. It decayed slowly, reluctantly, like a note that refuses to stop ringing. And here is the truth. Science thrives on anomalies. Anomalies drive revolutions. Newton noticed an apple fall. Einstein noticed that Mercury's orbit wobbled. The anomalies of 2025 may one day be remembered the same way, not as curiosities, but as catalysts. Perhaps they will spark a new physics of plasma. Perhaps they will teach us that interstellar objects are not random visitors, but carriers of resonance. Perhaps they will remind us that the universe is wired tighter than we dared to imagine. Or perhaps not. Perhaps the skeptics are right, and we have embroidered meaning into noise. Perhaps the novas, the comets, the flares, the auroras were just dice rolls stacked by chance. Perhaps we are children staring at clouds, seeing dragons where there are only vapors. But even if that is true, does it matter? Because meaning is not only in the universe, it is also in us. To witness a rhythm, even an accidental one, is to feel wonder. And wonder is the first step toward discovery. By the winter solstice, Atlas had faded into the outbound dark, a receding ember on its way back to the stars. SWAN had retreated into telescopic obscurity. The sun had returned to its quiet simmer. But the memory remained, a season when the sky exploded 3 times, when comets blinked, when planets glowed, when the universe seemed to lean close and whisper a secret. We may never prove what it meant, but we will not forget that it happened, and perhaps that is enough, because the lesson of 2025 is not that the universe gave us answers, it is that the universe gave us a question. And that question still lingers, pulsing like a heartbeat in the plasma wind. Coincidence or choreography?